this video, I would like to show you how to find the equation of a line from a set of data. So what we are going to start with here is a set of data that you're given. This is some data in a tabular form, and it gives us the time and position for a tumble buggy that's moving along at constant velocity. So here you can see the data table, and below here I have graphed the data. You can graph this just on regular graph paper, and you want to be sure when you're graphing data like this and you're going to try to find the equation that you use as much of the graph paper as you can to show your graph, so that you don't have your graph all jumbled up or squished up just down in the corner. So spread it out nice and big. So the first step here is going to be to, once you have your data plotted, is to try to use a straight edge and try to draw the best fit line. So obviously I'm not doing this with a straight edge here, I'm just drawing a line on top of it, which hopefully, let's give this another try here with the shapes I want to use. There we go. So I'm going to draw a line here that tries to go through these points, and you're not going to be able to make it go through all the points, but you want to move your straight edge around and see if you can get it to go through as many points as you can, and you can change the angle around and that kind of thing. If you can't go through all the points, which you probably won't be able to, what you want to try to do is have it go through as many points as you can, and then have some data points be above the line and some other data points be below the line. So let me shift this line around just a bit here and see if I can get something that looks, like it closely approximates this data. This is obviously an approximation. And when you draw this line, you want to be sure to extend your line beyond where these data points are, so that they go beyond all the way across your graph paper like this. Alright, so now we have our line on our graph, and we're trying to find the equation of the line. To find the equation of this line, we need to read off the coordinates of 2 points on the line. Generally, when we do this, we don't choose the coordinates of the data points. We choose two other points on the line. So an easy way to do this is to look and see where your line crosses areas on the graph paper that are easy to read the coordinates from. So if you see this point up here, my best fit line crosses a juncture here on the graph paper that will be easy to read the coordinate, and there's another point down here that will be easy to read the coordinate as well. So we're going to take those 2 points right there, and we're going to get the coordinates of. Let's carefully read the coordinates of these points, and you can see up here the x-coordinate of this point is 10, and the y-coordinate is 2.2, because this is 2, and each one of these grid lines is going to be 0.2. So the coordinates of this point are 10 and 2.2. And then if we look over here, the coordinates of this point here are 0, because it's on the y-axis, and the y-coordinate is below the 0 line here, so the coordinates of this point are 0 and then negative 0.2. Now we are ready to use the coordinates of our points to find the equation of our line. So we're going to use the equation y equals mx plus b, and the first step is to find the slope of the line. So we'll use the equation for slope, which is usually given the symbol of m, and the equation for slope is the change in y over the change in x. So the important thing to remember here is that it doesn't matter which point you choose as number 1 and which one is number 2. You just need to be consistent within the equation. So you're welcome to switch these two around and have this one be point number 1 and the other one be point number 2, as long as you're consistent within the equation. So we're going to take our change in y values, y2 minus y1, which is negative 0.2 minus 2.2, and I put the units in here meters so we can keep track of that. And in the denominator we have the change in x values, x2 minus x1. So the x value for point number 2 is 0, the x value for point number 1 is 10, so we have 0 minus 10 in the denominator, and that's in seconds. So when we do that calculation there, we get negative 2.4 meters divided by negative 10 seconds, which gives us 0.24 meters per second. So it makes sense that this slope should come out as a positive value, because that's what we expect for a slope for this kind of line. Our next step is now to find the y-intercept. We will use our equation y equals mx plus b, and we have the value m for the slope, and now we're going to choose one of our 2 points and use those coordinates x and y for the x and y values in this equation, and then we can solve for b. So the way this is going to work, you can pause this video at any point and follow through this math if you need to see it a little more slowly. So here's our equation y equals mx plus b, and I'm going to choose point number 1 here for x and y. So substituting in for y, I use the 2.2 equals, and substituting in for m, I'm using the slope that we calculated here, 0.24 times the value for x from our point, which is 10, and then plus b, which is our variable. So we multiply these two together and get 2.4, and then when we subtract from both sides, we get the answer that the y-intercept b equals negative 0.2. Excellent. Now we have the y-intercept and we have the slope, and we are all set and have the equation for our line. So our final equation, if we want to look at this in terms of x and y, we have y equals 0.24 times x minus 0.2. And if we want to look at the equation of this line in terms of the actual variables given in the problem, then we would write it something like this. Position equals 0.24 times the variable time minus 0.2. And that's how we figure out the equation of a line. Now you can try a sample one on your own.